We begin with applications of the derivatives. Of course, you have a quiz tomorrow only about the derivative, which was tutorial 2. Tutorial 3, this is the quiz 3. Okay, this is after 2 weeks. Okay, we will continue what we began in the previous lecture, which was the application of the derivative. What was the application that we dealt with? It was the test of the function when it was increasing or decreasing function, and of course this was using the first derivative for the function f. Also, the second application that we dealt with was the second derivative test, f double dash of x. I can conclude the concavity from the second derivative. I can find which function is concave up in some intervals and or concave down using the second derivative. ما في شاشة؟ عندكم شاشة ولا لا؟
في شاشة.
ايوه
رنيم جربي انك تطلعي من الميتنج وترجعي مرة ثانية. Okay. Also, there is another test using the second derivative to find the maximum and the minimum values. Okay, I can also find the maximum or minimum value according to the value of the second derivative at certain points. Okay, we said if it was at the point it's minus, then it's maximum. If it's positive, it will be a minimum. Okay, I will review this information quickly now. Of course, we said that a function, if I have here the x-axis and the y-axis, for example, like this, I have a function like that. The values of the function is going up when I move to the right, from left to right. So here, if I have x1 and here I have x2, of course, x1 here is less than x2, and here the values of the function here, f of x1 and f of x2. I also have that f of x1 is also less than f of x2. This function is increasing. طبعا راح أعيدها بشكل سريع لأنه اكتشفت أن الريكوردينج المحاضرة اللي فاتت كان مقطوع من البداية. الريكوردينج بدأ بس من بدأنا بالسكند فانكشن تيست أو السكند ديريفاتيف تيست. فراح أعيدها بس بشكل سريع. Also, if I have a function going to down when I move from left to right, like this, then I said that this function is decreasing function. If I have here a point x1 and a point x2, and this is the value of the function f of x1, and here f of x2. I have, of course, here from this line that x1 less than x2 implies that f of x1, which is this point, is greater than f of x2, the opposite. This is the decreasing function. How to know that the function is increasing or decreasing at a certain point? Let's say x equals to a. I make the first derivative test, f dash of a. If it was positive, then the function is increasing at this point. Okay, but if it was negative, minus sign, it will be decreasing at this point. Decreasing. Okay. That what the decreasing function. Okay, the relative or local maximum or minimum, as we said, to find the relative or local maximum or minimum or maximum means more than 1 point with of maximum or and minimum. We also call them extremum point, extrema, more than 1 point. The relative or local, first I find f dash of x. I will find the first derivative, then I will make it equal to 0. I find the zeros of the first derivative. This gives me the critical point. Critical points. Okay, from the critical point, I substitute. First, I apply the number of line of numbers. For example, here I have at x equals a and x equals b critical points. Then I make the function test, the first derivative test here. For example, at this interval it was positive, and this interval it was negative, and this interval, for example, it was positive. So here it will be increasing, here decreasing, and here increasing. Okay, I make the first derivative test in each interval. Okay, how do I get this intervals from the critical point? I just indicate the critical point on the line and choose any number from these intervals and apply it or substitute it in the first derivative and find out the sign, only the sign that I'm care of. Here, if it's positive, it will be increasing, negative, decreasing. This is just an example. Here, negative, positive, it will be increasing. So here it moves from increasing to decreasing. The function or the point will be like that. This is a maximum point. And here it moves from decreasing to increasing. So the function at this point will be like that. So this will be a minimum. Okay, this is how to find the maximum and the minimum point. Find the critical point and use the first derivative test. There is another method to find the method 2 to find the maximum and the minimum using the second derivative. Okay, the second derivative. First, I find the critical point, of course. This is fixed for each method. Then I find the second derivative and substitute in it with the critical point. Okay, then f double dash of a, I will have one of these possibilities. It could be positive or negative. If it was positive, so it will be concave up, right? Since it's the second derivative. If it's concave up, it will be like that. So the point will be a minimum. Okay. إذا عوضت بالنقطة الحرجة في المشتقة الثانية وكانت القيمة موجبة، معناتها أن القيمة الحرجة هذه تكون minimum، قيمة صغرى. If it was negative, so it will be concave down and the critical point will be a maximum. This will be a maximum point. لما تكون الدالة مقعرة إلى الأسفل معناتها أن النقطة الحرجة اللي عندي تكون maximum. Okay, this is another method to find the extremum values. Okay, of course the function could have another extremum or extremum point, could be maximum or minimum at the end point. We said that this could be a critical point, of course, but at the end point, when I give you a certain interval, not from minus infinity to infinity, a certain interval from A to B, it could be the absolute minimum or the absolute maximum. Okay, For example, here in this function, this is a local maximum, okay? But at certain point, let's say here that I stopped here. This is an absolute, which is the end point, absolute maximum. Also for the minimum, this point is a minimum, and it's a local minimum. Since I have another value at the end point, this is the absolute minimum. Okay, that's meaning when the question was find the absolute maximum and the minimum, you find the critical point and find the end point, the value of the function at the end point, and compare them together, and choose the greater value and indicate it at the absolute extrema, which is minimum or maximum. لما يكون السؤال find the absolute، أوجد القيمة العظمى المطلقة أو الصغرى المطلقة، أوجد أول شيء الكريتيكال بوينت وأشوف قيمة الدالة عندهم، وأيضا إذا كانت عندي فترة محددة أوجد قيمة الدالة عند أطراف هذه الفترة، وأقارن القيمة الأكبر مثلا في الماكسيموم. إذا كانت قيمة الدالة عند طرف الفترة أكبر من قيمة الماكسيموم، معناتها القيمة العظمى المطلقة قد تكون عند طرف الفترة، والعكس بالنسبة للمينيموم. The same for concavity. We said that the function is concave up, like this. This is concave up if the function f double dash at that point is positive, okay, with a positive sign. And it will be concave down like this if the second derivative at this point is negative. It will be a concave down. Also, we said that the tangent, when it's concave up, the tangent is lie under the graph. When it's concave down, the tangent اللي هو المماس lies above the graph of the function. المماس يقع أسفل الدالة عندما تكون مقعرة إلى الأعلى بهذا الشكل، ويكون يقع أعلى الدالة عندما تكون مقعرة إلى الأسفل. The inflection point, we defined it as the point that the function changed the concavity from concave up to concave down. Like that. From concave up, at this point, it will be changed to concave down. This point, I called it the inflection point. Or from concave down, at this point, to concave up. This is also inflection point. And the tangent is crossing the inflection point. Okay, this is, we already said that. And this was an example. Graphs. Okay, we did all these examples. Okay, we stopped at the previous lecture. That was the last graph that we sketched in the previous lecture, right? Today we'll begin with this example. We still have 2 examples on sketching. Then we will begin with the optimization. We still have the third application, which is the optimization, اللي هي مسائل الأمثلية. Okay. The question here, of course, using the second derivative test, sketch the graph of the function f of x. This is the given function f of x. It's of the third degree, and it's a polynomial. Of course, to sketch a graph, I need the first derivative, f dash, and I'll find the critical point from it by equal it to 0, find the zeros of the first derivative. Also, I need the second derivative to make the second derivative test to find the maximum and minimum, and also to find the concavity for the function and the inflection point as well. First, I will find the first derivative, which is 3x squared minus 12x plus 12. To find the critical point, I will find the zeros of the first derivative. Okay? To find the critical point here, of course, I can here divide by 3. Dividing by 3. To simplify, it will be x squared minus 4x plus 4 equals to 0. I can factorize this equation, or cannot be factorized. Okay, I will use the formula.
2, I think.
Yes, it could be 2 and 2, right? Yes, that's right. 2 and 2. This x2, x2, and it should be of the same sign, so it will be negative sign, minus and minus. So I have here only one root, one duplicate root. Okay, I have here either x minus 2 equal to 0 or x minus 2 equal to 0. So I have only one duplicate root. X equals to 2 is the only critical point. Okay, this is a critical point. Now I have to find out whether this point is maximum or minimum. So I will make the second derivative test. The second derivative is 6x minus 12. Okay, the second derivative test means that I will substitute in the second derivative with the critical point, which is 2. 6 multiplied by 2 minus 12 equals to 12 minus 12, which is 0. So here the test fails. Okay, we said that the test fails when I have a 0. So I can't find out from the second derivative whether it's a maximum or minimum, but it could be an inflection point. So here the way to find whether it's a maximum or minimum is to find the first derivative test. Okay, if I have here the line of numbers and here x equals 2 on the line, and here from minus infinity to infinity, I choose any number here on the left, for example 0, and apply it in the first derivative. Okay, now the second derivative, now the test is fails, so I will leave it to the concavity. I return to the first derivative and choose a number in the intervals here and substitute it in the first derivative. When I choose, for example, 0, I have here 3 multiplied by 0, 0, 0, 12. So it will be positive. Here it will be positive. Also, when I choose any value, yes, any value greater than 2, for example, 3, I will have here 9 multiplied by 3, 27, minus 12 multiplied by 3, 27 minus 36 plus 12. Yes, it will be also positive. So here the function is increasing in both sides. So at x equals 2 is neither maximum nor minimum. Okay, ما هي لا maximum ولا minimum، لأن الدالة هنا تصاعدية باستمرار. هي مجرد نقطة حرجة للدالة تمثل صفر للمشتقة. Okay, so it could be an inflection point. Okay, this is the first derivative. Now I will make the second derivative test at 2. Okay, اخذ الاثنين، اخذ ارقام على يمين ويسار الاثنين واعوضها في المشتقة الثانية. If I choose for example 0, it will be minus 12, so it will be here minus. If I choose here for example 3, 6 multiplied by 3, 18, minus 12, it will be positive. So it will be here concave down and here concave up. Okay, so 2 is an inflection point. Again, here I will say that at x equals 2, inflection point. I know here two information about the graph of the function. It's always increasing. دالة تصاعدية باستمرار أو تزايدية باستمرار. And also at the point 2, it changes from concave down to concave up. Inflection point. I can begin the sketch of the graph, but I can also find more information. So here I will find more information to be more accurate graph. راح أطلع معلومات أكثر عشان تكون عندي رسمة أدق، بس مش ضرورية. More information. I will find y-intercept اللي هي التقاطع مع المحور الصادي أو المقطع الصادي intercept, and also x-intercept. Okay, how to find y-intercept? Y-intercept, how to find it? Just substitute at the function with x equal to 0. Find f of 0. Okay, this will be the y-intercept. وين أعوض بالضبط؟ في الدالة الأصلية. y-intercept والx-intercept from f of x. ما أستخدم هنا المشتقات في المقاطع السينية والصادية. From f of x. Okay. أعوض في الدالة الأصلية بالزيرو. f of 0, it will be 0 minus 0 minus 0 minus 5. It will be minus 5. So the point of the intersection is 0 at the x-axis and minus 5 at the y-axis. Moreover, if I want to find the x-intercept meaning the intersection with the y-axis, where the function intersects with the y-axis. If I want to find the intersection with y-axis, with x-axis, sorry, I find the zeros of the function f of x. هنا لاحظوا أوجدنا المشتقة والمشتقة الثانية وأوجدنا أصفارها عشان increasing والconcavity. But here, the zeros of the function gives me the x-intercept. So I will take the function x to the power 3 minus 6x squared plus 12x minus 5 equals to 0. I solve this equation and it's of the third degree. I can't use here cannot use the quadratic formula. Okay, there is a method in the linear algebra called the rational root. I can find the factors of the constant term here, then divide the equation with it. طبعا هي طريقة معقدة شوي ومش مجال دراستنا هنا. فراح أوجد إن ما راح أقدر أوجد أي أعداد أو أي قواسم صحيحة لهذه المعادلة. فالفكرة هنا في المثال أعطاكم عملية تقريبية. وهو المهم إني أعرف بس وين بالضبط تقطع المقطع السيني، المحور السيني بمعنى آخر. أنا أعرف هنا أن at 0 it will be minus 5. Okay, so the function here is negative. Let's find out the function at 2, which is the inflection point. Here for the inflection point, I need actually the y coordinate from x, from f of x, not f dash, f of x. I will find the y coordinate here to locate the inflection point. So here, f of 2 equals to 8 minus 6 multiplied by 4, 24, plus 12 multiplied by 2, also 24, minus 5. 8 minus 5, which is 3. Correct? Here 4 multiplied by 6, and here 2 multiplied by 12. That's right. Yes, it's 3. So here it will be 2 and 3. So I know here that here at 0 it's minus 5, and here 1, 2, it will be at 3. 1, 2, 3. This is the inflection point 2 and 3. So here the value of the function, if I indicate the points, I need this point, which is the inflection point, and this is the y-intercept. So the function here is differently crossing or intersect with the x-axis. So it's somewhere between 1 and 5. So I can here make the concavity like that, and the concavity here concave up like that. Okay, it's not have to be exactly the point. اوكي، هنا في المثال عندكم عملها بطريقه تقريبيه، اخذ 4 قيم وقاعد يجرب فيها ايها اقرب للصفر، فمش ضروري تعملوا هذه الاشياء، انتم اساسا ما راح تكون عندكم آلة حاسبه. فالمهم هنا the most important is to locate the inflection point, which is 2 and 3. I need, of course, the y coordinate here for the inflection point, which is 2, and locate it. This is the most important point. And also I use the y-intercept, which is here 0 and minus 5. This is the point 0 and minus 5 at the y-axis. So it's intersect with with x-axis at some point here. Okay, and it's concave down. The most important thing is that it's concave down like that. And after 2, it will be concave up. This is the most important thing in sketching this graph. أهم شيء في هذا الجراف الانفليكشن بوينت، إن أخليها هنا concave down وهنا concave up، والدالة كلها تكون تزايدية، وإنها تقطع المقطع الصادي في هذه النقطة. أوكي، هذه المعلومات اللي متأكدة منها واللي أقدر أمثلها بشكل صحيح في الرسمة. أوكي. This is the inflection point that we found in the solution. أيوة، متصاعدة لفوق أو تزايدية إلى الأعلى. Okay, this was the y-intercept, التقاطع مع الصادات. And also this was the rational roots theorem from algebra. This method that I told you، ناخذ قواسم الحد الثابت اللي هي طبعا فقط الواحد والخمسة بإشارتين، موجب 1 أو سالب 1، موجب 5 أو سالب 5، وأجربها كلها، أقسمها على هذه، أقسم هذه كثيرة الحدود على x ناقص 1 وأشوف إذا يطلع لي بدون باقي، طلع فيها باقي أجرب x زائد 1، وهكذا. عندي 4 عمليات قسم وكلها راح تكون بباقي، معناتها هنا ما راح أقدر أوجد عدد غير كسري، كلها راح تكون أعداد غير كسرية اللي هي الراشونال نمبرز، الراشونال روتس. فهذه النظرية ما راح تنفع في حل هذه المعادلة، فما لها إلا الطريقة العددية، إني أجرب قيم. بما أنكم ما أخذتوا هنا طرق عددية، فالمثال عندكم هنا فقط جرب قيم عشان يوجد قيم قريبة من الصفر. أقرب قيمة للصفر خلاها هي التقاطع مع المحور السيني. مش ضرورية هذه الخطوة، أهم شيء إني أعرف إنه يقطع السينات في مكان بين الصفر وبين الاثنين، اللي هي بين المحور الصادي وبين الانفليكشن بوينت. هذا أهم شيء، مش ضروري إني أقعد أجرب قيم وأنا ما عندي آلة حاسبة. And this is the sketching. أهم نقطة عندي هي المقطع الصادي والانفليكشن بوينت، وأنها تكون تزايدية increasing and it's concave down. It's concave down here from the at the left of 2 and concave up at the right of 2. اوكي، هذا اهم شيء عندي في السكتشنج الدالة. اوكي. Okay, this is the last example about sketching. Then we will begin with optimization. Okay, first I have here a definition of a function f and also it's of the third degree. بس هذا المثال أسهل من اللي قبل. Also I have an interval defined only on this interval. It's not from minus infinity to infinity. I have here indicated interval from -2 until 6 with equality. So it's a closed interval from -2 until 6. The question here is, find the intervals on which the function is increasing or decreasing and find the maximum and minimum, if any. The question here is to find the intervals of increasing and decreasing for the function and also find the maximum and the minimum. Here طبعا at the same step. Okay. And related to it, I can find this question. What is the absolute maximum or minimum? Okay. راح أحلهم هذه اللي هي A and C at the same step. Okay, it will be the same. Okay, later we will read B and D. So here I will begin with A. I will find the intervals of increasing and decreasing. So I need here the critical point. So I will find the first derivative, f dash. I find the derivative of this function, 3x squared minus 6x minus 9. This is the first derivative of this function. Then, this is the first derivative. I will find its zeros to find the critical points. Okay, this is a second degree polynomial. It's easy to find its roots. I will divide by 3 to simplify. It will be x squared minus 2x minus 3 equals to 0. Okay, I can here factorize x and x. Of course, I have here 3, so the only possibility is 3 and 1. And the sign should be different. So here I have minus, yes, the minus with the greater number. الإشارة السالبة، بما أن هذه إشارة سالبة، الإشارة السالبة عند العدد الأكبر. Okay. So I have here two different critical points, which is x minus 1 and x equals to 3. Right? These are two critical numbers. So now I will find the intervals of increasing and decreasing. I will locate it at the line of numbers. Here I have -1 and here I have 3. And make the first derivative test. Okay, here from -infinity to infinity. I will find the sign of f dash of x. I choose any number less than -1, for example, -2, and substitute it here, okay, or here. If I substitute here with -2, for example, -2 square is 4 plus 4. بما اني ربعت فهي الاشاره راح تكون موجبه. 12 it will be 12 minus 6 multiplied by minus 2 will be plus 12 minus 9. Yes, it will be plus 15. So here the sign will be positive. So the function here will be increasing. Okay, if I choose any number here between minus 1 and 3, for example 0, if I substitute here with 0, it will be minus 9. Okay, here 0 minus 0 minus 9, it will be minus. So the function here is decreasing, sorry. Now I still have this interval. Of course, I don't have all this interval from minus infinity to infinity. I only have from minus 2 to 6. Okay, so here I have from minus 2 to 6. For example, here if I test at 4 square is 16 multiplied by 3. 16 multiplied by 3 minus 6 multiplied 16 multiplied by 3 minus 6 multiplied by 4 minus 9. Is it positive or negative? Here 24 plus 9 this will be 33 and this is 80.
I think it's positive.
Positive, yes, it will be plus 15. You're sure? Okay, this will be positive, so the function here will be increasing. So I find here the intervals. This is the question, intervals which the function is increasing or decreasing. So I can here say before the maximum or minimum from here from minus 2 until minus 1, minus 2 until minus 1, and union from 3 until 6, the function will be increasing. Okay, increasing. But from minus 1 to 3, I can here make the bracket either open or closed. It doesn't make any difference. Okay, it will be decreasing. Decreasing. Okay, now for the second part, which is maximum and minimum values. Since it changes here from increasing to decreasing, so at x equal minus 1, which is minus 1, and we find here the y coordinate, is maximum, local maximum. I said local. Until now, it's local. At x equals to 3, which is 3 plus 3, and with y coordinate, it will be local minimum. Okay. Someone find here the y coordinate from the function f. أعوض هنا في الدالة f بالسالب 1 وبال3 عشان أوجد الإحداثيات الصادية للنقاط العظمى. Okay, now I want to find if these are the local or the absolute, minimum or maximum. So I have to test the function at the end point. Also, I have to test the end point. I will just write at end points. Which one is 6? Minus 1? So minus 1 and 6. And the second value At the end point, I make the test of the function f at the endpoint, the first endpoint at 2, and f of 6. These are the endpoint. Okay, you're sure about that? This value minus 26. Okay. F of minus 2. Someone find f of minus 2. Minus 2, of course, to the power 3 minus 3 multiplied by minus 2 square minus 9 minus 2 plus 1. It will be minus 1. So here equals to minus 1. And here I have to substitute with 6, which is 6 to the power 3, 55. Okay, 6 to the power 3 minus 3 multiplied by 6 square minus 9 multiplied by 6 plus 1. It will be 55. Minus 26, you mean this one, right? Okay, we still have here. Now I compare these values. I have here a maximum. So the maximum value at the y-axis is 6. And here at the endpoint, the first endpoint is minus 1, and the second endpoint is 55. I have here 55 is greater, much greater than 6. So this point is the absolute maximum. The absolute maximum at the point 6 and 55. For the minimum, I have here minus 26 and I have here minus 1. Which one is less? Minus 1 or minus 26?
26.
Yes, minus 26. The absolute minimum is actually at the critical point. The absolute minimum is 3 and minus 26. You were sure about minus 26. This will be the absolute minimum. Not this. This is not minimum. Okay, just an endpoint. Okay. Now to find the intervals on which the graph of f is concave up or concave down. Of course, we will use f double dash. And the point of inflection, if any, in وجدت. Okay, now I'll keep the important information here to sketch. هنا أحتاج اللي هي النقاط العظمى، رح أكتبها هنا عشان بعدين أمسح هذه ويكون عندنا مساحة للرسم. عندنا اللوكال maximum minus 1 and 6. عندنا اللوكال أو الأبسولوت minimum 3 minus 26. أيضا عندنا الإند بوينت end points اللي هي minus 2 minus 1 and I have here 6 and 5. I need these for the sketching. Okay. I still need here the first derivative to find the second derivative. Now to begin with the second derivative test, now I will solve B. I will find the second derivative, f double dash, from here. It will be 6x minus 6. I will find its zeros to find the inflection or possible inflection points. So it will be 6x equal to 6, dividing by 6 the both sides will be at x equals 1. Okay, this could be an inflection point. To find if it's inflection point or not, I will test the sign of the second derivative at the right and left of x equal to 1. This is 1, and now I will test the second derivative sign. I choose any number greater than or less than 1, but it have to be inside this interval. For the simplicity I'll choose here 0. أسهل رقم على يسار الواحد ممكن يكون 0. And substitute it here. It will be minus 6. So here it will be minus. It will be concave down. And greater than 1, for example 2. 2 multiplied by 6, 12, minus 6, it will be plus 6. So it will be here concave up. So at x equals 1, which is 1, and here the y coordinate, it will be inflection point. And here the intervals of concavity, I have here from minus 2 until 1. It will be concave up, sorry, down, concave down. I have here minus, so it will be concave down. And from 1 to the second endpoint, which is 6, it will be concave up. Okay, here concave down, and here concave up. What was at 6? Okay, at 6 عوضته في الدالة الأصلية. هنا أوجد الواي coordinate من الدالة الأصلية. أعوض هنا بالواحد. It will be 1 minus 3 minus 9 plus 1. أكيد 6. I have here 1 minus 3 minus 9 plus 1. Will be here 2 minus 3 minus 1 minus, it will be minus 10, minus 10. So here I have here minus 10. Okay. Yes, 1 and 6 for interval. You can write it open or close here, but it have to be closed at 1 or at 6. I have here closed interval at 6. Okay, it's not important whether you make it closed or open at 1. It's an inflection point. Okay, it could be here closed or open. So I have here all the information that I need to sketch. You can find the y-intercept and x-intercept, but I think my information here are enough. I indicate now the point. I have here a local maximum at minus 1 and 6. This is minus 1 at the x-axis and 6. 1, 2, 3, 4, 5, 6. Well, let's, since I have here a very large point, which is 55, let's, for example, say that this is 6 at here. This was 6, so this is minus 1 and 6. This is a point, not interval. Okay, this is this point, which I said that it's a local maximum. We said that the absolute maximum was at 6 and 55. So here I indicate 6, 1, 2, 3, 4, 5, 6, and 55. Let's say that 55 is here. So it could be a point somewhere here. This is the end point, which is my absolute maximum here in this interval. And I have also an absolute minimum at 3 minus 26. I have here 3. This is a 3. And minus 26, let's say that it's at this point. مش ضروري تكون المقاسات دقيقة بالضبط. This is the point. 3 minus 26. أهم شيء البوزيشنز إن في أي ربع من المستوى أضع النقاط تكون صحيحة. So the second endpoint at minus 2 and minus 1. This is minus 2 and minus 1. Okay, so let's say that this point is minus 2, minus 1. Okay. So I begin now. I said that this is a local maximum and the concavity here is down. I begin of sketching. I begin from the first endpoint, which is minus 2, minus 1. Then increase the function until minus 1 and 6. We said that at minus 1, it will be a local maximum. So I stop increasing here and start to decrease the function. Okay, decrease the function, but still concave down until 1. We didn't indicate 1 and minus 10. Okay, this is 1 and somewhere here is minus 10. This is an inflection point. So until here, it will be concave down. Okay, now I only change the concavity to up. Okay, من بعد الانفليكشن point أغير فقط الكونكافيتي إلى concave up. And stop here the decreasing function, start to increase like that until this point. Okay, I stop here since I have a closed interval. أبدأ هنا من -2 من النقطة -2 اللي كان الإحداث فيها الصادي -1. وصلت إلى الماكسيموم مع concave down. أظل concave down but decreasing until the inflection point. أظل decreasing لكن أغير concavity to up until the minimum. لما أوصل للمينيموم أبدأ بتزايد إلى الأعلى and still concave up. Okay, this is the main sketch of the graph. أهم شيء الخصائص الأساسية للدالة تكون صحيحة. Now let's check our graph similar to what we sketch. Okay, this is the endpoint and this is the local maximum, absolute maximum, and this is the minimum, which was also the absolute minimum. Okay, now we finish the example of sketching the graph. As we said, the most important thing here is the increasing and decreasing interval, including the maximum and minimum points, اللي أوجدها من critical point, and then find the second derivative, find the concavity, concave up or down, and the inflection point between them. This is the most important thing in sketching the graph. طبعا في هذا المثال ما استخدم اللي هي الواي انترسبت والاكس انترسبت زي المثال اللي فات، بس ممكن تضيفوها كإضافة عشان تكون رسمة أدق. بس في كل الأحوال هي مش ضرورية عندكم بهذا المنهج. Now we begin with the optimization problem. What's the meaning of the optimization? The optimization بالعربي معناتها الأمثلية، الأمثلية في الحل. The best solution. For example, if I have an area لو كان عندي مساحة معينة وعندي أطوال, I can find the best dimension that makes the area maximum, the maximum area. أقدر إني مثلا باستخدام مسائل الأمثلية إني أوجد الأطوال الأمثل عشان تعطيني أكبر مساحة ممكنة. هذا معنى الأمثلية. For example here, the first example is general actually. Find two positive numbers. Notice here two positive numbers, okay, x and y, that maximize this function. Okay, if I have this relation between x and y, x plus y equals to 6, the first important thing that I have to notice is which function I have to maximize or minimize according to the question. أكثر شيء أو أول شيء لازم أنتبه له الدالة المطلوب مني إني أوجد أعلى قيمة لها أو أقل قيمة لها. هنا في هذا المثال maximize أعلى قيمة للدالة، فالدالة اللي مطلوب مني أوجد الماكسيمم فاليو لها هي الدالة Q. أوكي، والبقية هي معطيات. So I construct this function which is Q equal to x squared multiplied by y. I have here two variables. عندي هنا متغيرين أو مجهولين x تربيع مضروبة في الواي. And I have here an equation with x and y, x plus y equal to 6. But this is my function. To find the maximum or minimum values, as we said before, we use the first derivative. So I find the first derivative for this function to find its maximum. But here I have two variables, so I can't here differentiate. I must have only one variable. So to make it only one variable, I use this equation. First, I find y in terms of x. Y equals from here, y equals to 6 minus x. Since I have x plus y equals to 6, I can find the value of y. From this value of y, I can find the value of the function q in terms of one variable x, which is x squared multiplied by y. I said that y is 6 minus x. This is y. Okay, multiplied by y. Okay, instead of y, I will write 6 minus x. Okay, then simplify x squared multiplied by 6 minus x to the power 3. This is the function q of x. Okay, now to find the maximum of this value, I will find the derivative. Okay, the maximum of q of x, I will find the derivative of q. The derivative, I just differentiate this function, which is 12x minus 3x squared. Okay. Again, to find the maximum, I find the critical point. Okay, I find the zeros of the first derivative, which is, here I can take common factors, which is 3x. هنا عامل مشترك ممكن اخذ 3 من الطرفين وايضا x من الطرفين. 3x multiplied by 4x 4 minus only 4 here. I take x as a common factor minus x equals to 0. So either 3x equal to 0 means that x equal to 0, or 4 minus x equal to 0 means that x equals to 4. These are the critical points for Q. Critical points. Okay. I still need to find which one is minimum and which is maximum. Okay, the easiest way is to find the second derivative. I will use the second derivative test. Q double dash of x. I differentiate here. It will be 12 minus 6x. Okay, so I substitute in the second derivative with 0, which is the critical point, equals to 12 minus 0, 12, which is positive. Okay, so here the second derivative at a critical point is positive, so it's minimum. So it did not maximize the value. This is not my point. So I test the second point with the second derivative test, which is x equal to 4. It will be from here 12 minus 6 multiplied by 4. 12 minus 24 will be minus 12. It's negative, right? Negative, yes, minus 12. So second derivative at the critical point is negative, so it's a maximum. Okay, this is a maximum point. So here's my point, which is at x equals 4. At x equals to 4, Q of x maximize. Okay. I still need to find y, since the question is find x and y. How to find y? From here. Okay. I substitute here x plus y equal to 6, or immediately here to find y. X plus y equals to 6 means that 4 plus y equals to 6 means that y equals to 6 minus 4, which is 2. So at x equals 4 and y equals 2. These values or positive numbers, notice that I have it have to be positive, since the question find two positive numbers that maximize qx square, q equals to x square multiplied by y. If the x was 4 and y was 2, this gives me the maximum value for q. Okay, this is the solution. Okay, the same answer. Now, how to apply this to real problem, to reality problem. Here I have maximizing area. What's the meaning of area? Area اللي هي المساحة. Okay, if I have, for example, a rectangular, like example here, rectangular garden. So I have like that, rectangle. What's the area of a rectangle? Is the multiplication of the height with width. Let's say that this is y and this is x. So the area A here is the area, equals to x multiplied by y. Okay, this is the area. The question is, find the dimensions of the rectangular garden of greatest area that can be fenced off with all 4 sides with 300 meters of fencing. Okay, what's the given information here? 300. 300 actually is the fencing around the garden. Okay, this is given. What's the question to maximize or minimize? Is greatest area. Greatest area means the maximum possible area. So the question here, which function I have to maximize or minimize, is the function A. أول شيء في مسائل الماكسمايزنج or minimizing إني أحدد الدالة المطلوبة for maximize or minimize لأن هي اللي راح أشتقها. فهنا المطلوب مني دالة المساحة greatest area، فأحدد إن ال A هي الدالة المطلوب إيجاد الأمثلية لها أو maximum value for it، فأقول إنها هي الدالة اللي راح أشتقها A equal to XY. What's the given information? 300 meters of fencing. Fencing اللي هو السياج أضع على محيط الجاردن. Okay, I put the fencing around the garden. So it's only the perimeter. فقط محيط الحديقة. Only the perimeter. So here the perimeter equals to 300. What's the perimeter? قانون المحيط المستطيل هي مجموع أطوال الأضلاع. Is the addition of all the length, all the dimensions. So I have here 2x, which is x plus x, plus 2y equals to 300. So I have here a relation between x and y from the fencing. 2x plus 2y equals to 300. Okay, and this is the question. I don't have here the area. I have to find the best area or the greatest area. Okay, I have here the area similar to the previous example with 2 variables. I need it in only 1 variable, so I use the perimeter. استخدم المحيط عشان أوجد الواي بدلالة الإكس وأعوض في الA. Okay, from here I can find y in terms of x equals to 300 minus 2x dividing by 2. For the both sides, I have that y equals to here 150 minus x. Okay, this is the value of y. I substituted in A of x equals to x multiplied by y, which is 150 minus x. Okay, from here. So to simplify, it will be 150x minus x squared. I just multiply x with this bracket. Okay, now to maximize this area, to find the maximum value of this area, I have to differentiate, find the derivative. Okay, now to maximize, I will differentiate the function a dash of x, which is 150, the derivative of this, minus 2x. Now to find the critical point, I find the zeros. So it will be at x equals to 150 divided by 2. هنا بعد ما سويت بالصفر نقلت 2x إلى الطرف الثاني فصارت positive 2x equal to 150 وقسمت على معامل الx which is 75. Okay, so I have that x equal to 75, right? It's 75. Okay, this is the first dimension. The second dimension, which is y, I can find it from here or from here. 150 sorry, from here or here. 150 minus 75 will be also 75, right? So I have here two equal dimensions. So the rectangular area will be a square area. Okay, it will be a square. Yes, 75. Here I have x equal to 75 and also y equal to 75. The maximum area is only the square. عشان أحصل على أكبر مساحة ممكنة باستخدام مساحة أو باستخدام محيط مقداره 300، المساحة العظمى الوحيدة هي اللي تكون مربعة، تكون الأضلاع متساوية 75 و75. Okay. This is the exact solution. طبعا هنا يسمي الدالة المطلوب maximizing or minimizing for it يسميها objective equation. We called it the objective equation. الدالة المستهدفة. طبعا هو هنا كان يستخدم الجرافس في التحديد ما إذا كانت قصوى أو ما إذا كانت عظمى أو صغرى. But you can instead of it using the second derivative test. It's easier. طبعا هنا في خطوة المفروض بعد ما طلعنا اللي هي critical point at x equal to 75, we have to check that if it's whether it's maximum or minimum. So I have here to find the second derivative to check, only to check. هذه خطوة إضافية للتأكد من أن to check if it's maximum or minimum، لأن الكريتيكال بوينت ممكن تكون maximum أو تكون minimum. Okay. If I use the second derivative test, it will be minus, since it will be minus 2. I have here a double dash of x will be minus 2. It will be negative for all. It will be negative for all values. معناتها لأي قيمة راح تكون concave down. معناتها أكيد راح تكون sorry راح تكون maximum. Okay, concave down like that. So it's for sure maximum. Okay. Okay, another application. The previous example was maximizing the area. Also, I can use it in the problem of minimizing the cost. تقليل التكلفة، أقل كلفة ممكنة أو أقل خسائر ممكنة. It could be an application for that. Okay, the question here, a rectangular garden. Also here I have a rectangular garden, but here given the area is 75. Okay, here different. This example is a little bit different. I have here 75 square area. 75 square feet is to be surrounded on 3 sides by brick walls costing $10 per foot. So here I have 3-sided of a rectangular area. Let's say here that this is x and this is x and this is y. Okay, at these 3 sides I will use the brick wall fencing or surrounded with the brick wall. Okay, راح استخدم the brick wall for these 3 sides. The fourth side, of course, this costs $10 for each one. Okay, for the fourth one, which is this one. Okay, this side, the fourth side, which is y, it will be only fencing. راح أضع سياج عادي، مش ضروري يكون brick, costing $5. Okay, so this costing $5 and this cost 10, this cost 10 and this costs 10. Okay. Barefoot. Okay. Find the dimensions of the garden such that the cost of the materials minimized. المطلوب مني هنا أوجد dimensions الأبعاد x, y, x and y of the garden such that the cost, this is my function to maximize or minimize, of materials minimized. Okay, I want to minimize the cost. المطلوب مني أوجد أقل قيمة ممكنة للتكلفة، الأبعاد اللي تعطيني أقل قيمة ممكنة للتكلفة. هنا ما قسمنا ال 300 على 4 لأن هنا التكلفة مختلفة. أنا هنا راح أحسب التكلفة مش المحيط ولا المساحة. أوكي، وهنا ما في 300 أصلا، 300 مختلفة المثال اللي قبل، ولا تتكلم عن المثال اللي راح، صح؟ أنت قصدك المثال اللي راح، صح؟ أنا ما كنت أعرف أن أكبر مساحة ممكنة هي اللي تكون مساحة مربعة، عشان كذا ما أقدر أن أقسم على 4 من البداية. أنا راح أوجد قيمة البعد الأول، عشان أرجع لك المثال اللي راح. أنا كنت أوجد البعد الأول اللي هو هذا البعد X عشان أوجد القيمة الثانية اللي هي أيضا Y اللي تعطيني أكبر مساحة ممكنة. أنا وجدت أن البعد الأول يساوي 75 وبالمثل أوجدت منه البعد الثاني أيضا 75، معناته أن المساحة تكون مربعة، استنتجت أنها مربعة، مو من البداية أفرض أنها مربعة وأقسم على طول على الأربعة. أوكي، هنا خطأ أني أقسم على الأربعة من البداية. أنا ما عندي معلومة أنها السكوير area is the maximum area. ما عندي معلومة أن المساحة المربعة هي اللي تعطي أكبر مساحة ممكنة. أوكي. Okay, back to this question. Okay, I indicate the function of optimization, which is the cost function. Okay, the function of the cost of the material. Okay, معناتها أن C is the function of minimized. Okay, I want to minimize the function C. This is the question. How to find the value of this function? أنا هنا عندي التكلفة. I have here the cost. Each side have its cost. So I have here that the cost C is 10 multiplied by X. This is 10 multiplied by X. Okay. راح أضرب هذا الطول في 10 عشان أحسب تكلفة هذا الضلع. Plus also here 10 multiplied by X. Plus 10 multiplied by Y. Okay, this gives me the cost of this side. Plus 5 multiplied by Y. This is only fencing, a regular fencing, cost $5. So it will be plus 5 multiplied by Y. I now simplify this. I have here 20x plus 15y. This is the function of the cost. Okay, I have here two variables, x and y, making the function of the cost c. Now I have to make it in only one variable. Okay, I will use the given information, which is the area. I have here that the area is 75. Okay, given that the area, this information is giving, I know that the area x multiplied by y, which is given by 75. Okay, so this is the equation of the area. سؤال؟ Okay. From here من المساحة المعطاة أقدر أني أوجد إما قيمة الواي أو قيمة الإكس وأعوض فيها في الدالة C عشان أوجدها بقيمة متغير واحد فقط. For example, I will find y in terms of x, or you can find x in terms of y. I will find now y. It will be 75 divided by x. I know for sure that x is not 0 since it multiplied here by y and it equals to 75. So this is possible. Okay, this is the value of y. I move now to the function c and write it in terms of x. It will be 20x plus 15 multiplied by y. What is the value of y? I said that y is 75 divided by x. 75 divided by x. This is y. Okay. Okay, now I will simplify here. It will be 20x plus 15 multiplied by 75. It will be, okay, I write, yes, 1125 dividing by x. Okay, this is my function. This is the function c, the cost function in terms of x. So to find the maximum or the minimum here, I have here to find the minimum. I will find the critical point. So I will differentiate the cost function of x, which is 20. Derivative of 20x is 20. The derivative of this rational, I have here x at the denominator. I will write it immediately. I have here that the derivative of 1 divided by x equals to minus 1 over x square. تقدروا تتأكدوا تكتب x to the minus 1 and make the derivative. You will find that it's equal to minus 1 divided by x square. Okay, so I write immediately the solution. Minus 100 or 1125 divided by x square. عرفتوا هذه من وين جت؟ من مشتقة 1 على x. This is a constant, so I don't change it. Plus 1 over x, the derivative is minus 1 over x square. This is the derivative. Okay, now I will find the critical point by make it equal to 0. Okay, so it will be 1125 divided by x square equals to 20. I can here multiply here in a scissor multiplication. It will be x square equals to 1125 divided by 20. It will be كيف عرفنا انه التكلفة 5 للواي it's given. اوكي، انا هنا فرضت انه هذا الضلع هو اللي راح يكون fencing. طبعا اختار الضلع الاطول هو اللي يكون القيمة الاقل. اوكي، لو قلنا ان واحدة من الاكس هي اللي 5 معناته هذا ما راح يعطينا اقل تكلفة. اقل تكلفة اكيد اني راح اختار واحد من الاطول بما ان هنا اتكلم عن مستطيل the longest dimension. I here indicate that the longest dimension is y. So one of the y is multiplied by 5. Okay. Okay, here here it was minus, so I move it here with the positive sign. Yes, when I divide it, it will be 56.25. But this was x square. I will complete it here. X equals to the square root of 56.25 equals to Yes, using the calculator now, it will be 7.5. This will be the first dimension, which was x. Okay. I will use it to find y. Yes, I will use this x to find y. I will use this equation to find y. I have that y equals to 75 divided by x, which is 75. Mute your mic, please. 7.5. It's obvious that it's 10. Okay. نفس العدد لكن مع فاصلة عشرية أكيد راح يكون 10. Okay. So here my solution is the minimum cost will be at the dimension x equals 7.5 and y equals 10. Okay. Notice here I completed my solution with x equal to 7.5, which was the critical point. Okay. I assume that it was, or suppose that it was a minimum, but I have to check actually whether it's minimum or not. So check that this is a minimum, and it will be all really a minimum. Okay, check if it's minimum. Okay, I will leave it for you. Check that this point is minimum using the second derivative and complete this answer. Okay, this was the final solution. In your slides, notice here that in your slide they make the opposite. هنا عوض بقيمة الواي، عمل الدالة هنا دالة في الواي مش دالة في الإكس، بس هي نفس الطريقة أو نفس الحل بالضبط. إذا فاكرين هنا في المثال أنا شلت قيمة الواي وعوضت عنها بالإكس، صح؟ I write 20x plus 15 multiplied by the value of y, which was 75 divided by x. بس هنا عمل العكس، شال قيمة الإكس وعوض عنها بالواي. But it will be exactly the same. Okay, and also they use the graph to prove that it's a minimum. Here at 7.5, it will be any minimum. They use the graph, but you can use the second derivative test for easier way. Okay. Notice here the same solution. They find that y is 10, then substitute in the value here, x multiplied by y is 75, and find that x is 7.5. Exact same solution. معناته ممكن تستخدموا الطريقة اللي استخدمناها انكم تعوضوا عن قيمة الواي بالاكس، او مثل حل اللي في السلايد عوض عن قيمة الاكس عن قيمة اكس بواي، صارت عندي دالة سي في الواي. You make the easier for you. Easiest way. Okay, this I think it's the last example. The last example. Okay. Okay, now it's also the optimization problem, minimizing surface area. Okay. نتوسع أكثر الحين من المساحة والمحيط، راح ناخذ الحجم and the surface area. The solution or the question here containing a volume. Volume means الحجم. Okay. The question or the problem, a canvas went shelter for the beach. Okay. canvas اللي هي عبارة عن مثل الخيمة القماشية for the beach has a back. Notice here the dimension that are given, a back which is this, 2 square sides which is this one and this one, square sides, and a top. This is the only dimension for the shelter. This is the top. Okay. معناته عندي هنا shelter with this dimension. عندي فقط الدايمنشن الجهة الخلفية وأيضا التوب والتو sides. And the two sides are squares. So I indicate the dimension for the square as x, here x multiplied by x, and the top, the tallest dimension will be y. And this is, of course, will be also x since it's a square, and this is x, 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 and this is y. Okay, this is also y. Notice here I don't have a front or a bottom. Okay, this is the missing sides. ما عندي هنا لا الجهة الأمامية ولا الجهة السفلية. هذه الأبعاد أو الأضلاع المفقودة. The question is find the dimensions. Always the dimension here are x and y. I have a volume. It could have also z. But I have here a square sides, so x equal to z. I have only two dimensions, x and y. Okay? For which the volume will be 20 or 250 cubic feet. So the volume is given. It's not the function to minimize or maximize. And that requires that least possible amount of canvas. Least possible amount of canvas. So this will be my function to optimize. Amount of canvas. Amount of canvas اللي هي كمية القماش المطلوبة لتغطية الشلتر أو الخيمة. أوكي؟ عشان أحسب أقل الأبعاد اللي تعطيني أقل كمية من القماش. The least amount of the canvas. So this is my position or my function to optimize. Given, I will write the given information, which is the volume given by 250. Okay, given. The function to optimize, make it maximum or minimum, is the amount of canvas. The amount of canvas اللي هي كمية القماش المطلوب للتغطية يمثل المساحة السطحية, surface area. So I will call it denoted by S. Okay, capital S. Surface area is the amount of canvas. Amount of canvas. أو اللي هي surface area. I will now compute the surface area first to find the function. The surface area, to find the area of this shelter, I will just add the area of each side. Okay? عشان أوجد المساحة السطحية لهذا الشلتر راح أجمع فقط مساحة كل سطح من الأسطح المعطاة عندي. The first side, which is here x multiplied by x squared. So it will be x squared. The second one is also x multiplied by x, this side, plus x squared. Okay, the top side, it's a rectangular. It's x multiplied by y. So plus x multiplied by y. Also the back side, it will be y multiplied by x. So plus x multiplied by y. To simplify, I have here x squared plus x squared, 2x squared, also xy plus xy plus 2xy. So the first step is to indicate the function of optimization. أحدد الدالة المطلوب أني أوجد الأمثلية لها, which was the surface area, denoted by S. Then find its function. I don't have all the sides, I only have a certain sides. So I have to find the addition of each side for all the sides. The first side, x squared, plus the second side, x squared, the square sides. and the top and the behind side are rectangular. It will be x multiplied by y plus x multiplied by y. It will be 2xy. This is my function. Okay, this is the function s of x and y. Okay, now before finding the maximum or minimum value for s, I have to write it in one variable. But I have here two variables, which is here x and y. I will use the given information, which is the volume. I know that the volume is x multiplied by y multiplied by z. اوكي، الطول في العطف الارتفاعي يعطيني حجم المكعب. Okay, but I don't have here z, since I have here square on the side. I will have x equal to z, so x multiplied by x multiplied by y. Okay, multiplied by x. So it equals to x square multiplied by y equals to 250. So I can find that y equals to 250 divided by x square. This is the value of y from the volume. Okay. So I can substitute it at s to be only a function in one only variable, which is x equals to 2x square plus 2x from here multiplied by y. What's the value of y? It was 250 divided by x square. I will simplify. Equals to 2x square. Nothing will be changed here. But here, I will divide 1x from top and 1x from the bottom. And I will multiply 2 by 250. So it will be plus 500 divided by x. واضحة؟ اختصرت هنا x من البسط مع x من المقام وضربت الاثنين في 250. حصلت على 500. This is the function s. Now, to optimize, to find the least means the minimum of s, I will differentiate s dash of x. I will differentiate this. It will be 4x minus 500 divided by x square. I will differentiate here by the same way. The derivative of 1 by x or over x is minus 1 over 6 over x squared. Okay, derivative of 1 over x is minus 1 over x squared. Okay, and make it equal to 0 to find the critical points. So I will have here that 4x to the power 3 equals to 500. Dividing by 4, I will have x to the power 3 equals to 500 قسمة 4 بكم؟ I think it will be 100, yes, 25. I still have to find x. So here, x equal to the third root of 125. Okay, what's the third root of 125? Will be 5. 5 to the power 3 is 125, 125, right? So I find the value of x, which is 5. Yes, it's 5. Okay. I have here, before completing, I have to check whether it's minimum or not using the second derivative test. Okay. And it will be actually a minimum. And I will find y. I will find y from its value here. I have that y equals to 250 divided by x squared, which is 250 or from here x squared equals to 250 divided by 5 squared, which is 25. It's obviously equal to 10. Okay, this is the value of y. So here the dimension will be x equals to 5 and y equals 10. These dimensions give me the least possible amount of canvas. إذا كانت عندي الإكس 5 والواي 10 رح تعطيني أقل كمية ممكنة من القماش لتغطية هذا الشلتر. Okay. Okay, this was the last example. أهم شيء في هذه مسائل الأوبتمايزيشن إني أحدد الدالة اللي راح أشتقها. الدالة اللي يحتاج إنها تكون minimum or maximum أكونها وأشتقها، أحددها في البداية هي إيش المطلوبة، بعدين أوجد تعريفها من المعطيات، بعدين أشتقها. ضروري إني أكتبها فقط في متغير واحد. I write it first in only one variable, then differentiate. After differentiate, find the critical point, like here. Differentiate, find the critical point. I find the critical point here and check that it's minimum or maximum. If it was minimum, I will complete. If it's maximum, so there is no solution. If I check that it will be a minimum, using of course the second derivative test, I find s double dash and substitute with 5. It will be from here 4 minus 500 or plus 500 over x to the power 3. It will be positive, so it will be minimum. Okay. Then I will find y. It will be the final solution, x and y. Okay, that's exactly the same. Okay, that was the last slide. Okay, we finished our lecture. We finished here.